This video is introducing the use of Finance Solver in relation to reducing balance loans for the recursion and financial modelling component of further mathematics. So throughout this video, I'll be describing and using the TI-Nspire for the application of Finance Solver, but there is a very similar application with the same process steps on the CAS calculator. But I encourage you just to, if that is your CAS, that you look at the particular instructions to do with the Casio. So in the last video, we looked at reducing balance loans and recurrence relations, and we said that there is a general rule. However, we're not required to know that for further maths. What we are expected and required to do is utilise the Finance Solver application on our CAS calculator, to the point where the examiners are expecting you to note down each of the key components in the Finance Solver and the value that you entered as part of your working to show method, potentially for any exam 2 where you may get consequential marks. And so as we go through them, it's worth having noted somewhere in your bound reference, what does each section represent? But also knowing that within the calculator, it gives you a description if you are sitting in one of the boxes. So firstly, how do we get there? And what do each thing mean? So from within our CAS calculator, we're on a calculator page. And from the menu, we're going into our finance menu and selecting the first one there, Finance Solver. And so this brings up the application where we have a number of boxes that we can fill in. And so the first one here, N, that represents the total number of payments you're talking about. So it may be that you are doing 3 years worth of monthly repayments. So that's a total of 36 payments. And think about that as the iterations. It's the same as the small n in your recurrence relations. The next one, I, as a percentage, is the interest rate per annum. So we do not need to adjust this for any compounding periods, just the per annum interest rate to be entered. PV, here it's called the present value. I tend to refer to that as the principal value. So it is our initial value, our starting point for the problem that we are working through. And we have PMT, and that represents the payment. So what is that regular periodic payment that is being made on the particular loan that we're dealing with? We then have FV, which is the future value. So that represents the balance of the loan after N time periods or N payments has passed. The next two, PPY and CPY. In the context of further maths, they should always be the same value. And these refer to PPY, how many payments made per year, and CPY, how many compounding periods per year. If we are compounding the interest monthly, we will always also be making monthly repayments. So those 2 time periods will always be the same. The final value is asking when is the payment made. In the context of further maths, we are always paying our payment at the end, so after the interest has been calculated. That should always be set as default to end, and there is no need to change that. So looking at some conditions or times when we would use Finance Solver. Generally speaking, when you're reading the question and you're identifying that it is a reducing balance loan, you're wanting to think about how many pieces of information do I have? So out of those different boxes, out of all of that information, how many do I have access to? And there should be one left to solve for. In that case, it might be the value of the payment required to pay off the loan. It might be the number of payments needed to pay off the loan. It might be that you're actually doing an adjusted final payment, or you want to know something like how much interest is paid over the life of the loan, or the total cost of the loan. So these are things that we can definitely use the Finance Solver to help us access either an answer or a component of value that we need in order to calculate the answer. The final thing that we'll look at and included in this video is the impact of changing conditions throughout the life of a loan. So it may be after a certain time period the interest rate changes, or we want to pay the loan off quicker, so we increase our payment amount. And so there's some scenarios that we'll look at towards the end of this video. So firstly, as we work through this example, we want to follow a similar process that we were using for all of our other work in recurrence relations. So think about identifying the key information, but now we're going to be putting that in the context of a finance solver. So here we have Peyton would like to purchase a block of land and will borrow $350,000 to make this purchase. The interest on this loan will be charged at a rate of 4.9% per annum, compounding fortnightly. After 3 equal fortnightly payments, the balance of Peyton's loan will be $262,323.33. We're asked to find what is the value of the fortnightly repayment that Peyton must make. So firstly, let's think about in the context of those finance solver values, what do we have here and what are we missing? Okay, so thinking about that context, let's reread. Peyton will borrow the $350,000. So that's the initial value of the loan. So that's our PV value. When we're entering this into the finance solver, we want to think in the context of which direction does the value of the money go. So Peyton is getting this loan. So think, I am getting this money from the bank and I am going to spend it on whatever I want. In this case, a block of land. But that means that if I'm Peyton, I now have $350,000 in my pocket. So that is a positive amount. I'm getting that money from the bank. That then means if I'm thinking about what I'm paying, any money that goes back to the bank would be a negative value. But if we continue, the interest rate, so the 4.9% per annum, as we said, we put our per annum interest rate into the I for interest, and we're compounding fortnightly. So our compound periods and our payment amount per year, or payment periods per year, there's 26 of those per year. After 3 years, so here we're going to have, after 3 years of 26 payments per year, so a total of 78 repayments, the balance of Peyton's loan will be the $262,323.33. So Peyton owes that amount. So if I owe the bank that amount, that means my future value will be a negative value. I would have to give that back at that point. So negative 262,323.33. And what we're being asked to solve for is what is the payment amount. So what is this P and T value? So going across now to our calculator, we can enter that set of information in. Interesting to note, in your N box here, we can actually type 3 years. So we can actually just type in the number 3 years times 26 payments per year. And when we go to our interest, it will calculate that automatically for us. So we don't have to do that in a separate space. We can calculate it in that box for N. We had an interest rate of 4.9. We had a principal value of $350,000. We're going to come back and solve for the payment. We know at the end of that 3-year period, the balance was 262,323.33, and we need to adjust these. So payments 26 times and compounds 26 times per year. If I come back around to PMT, so I just need to make sure I am in that box that I want to calculate. And you can see down the bottom here it says press enter to calculate or to solve. So if I press enter, I get that value there. My payment is negative $1,704.14. So I want you to be in the habit of writing down exactly what you get in your calculator, a couple of more decimal places, and then giving your final answer so that you can show that you've rounded correctly. And so noting down what we got and then giving my final answer, so $1,704.14. Now note that payment amount, the PMT, is negative because I'm giving that money to the bank to pay off my loan. But when I state the payment, I'm stating it as a positive value, as a monetary value. The other thing as well, we always round our dollar values, our monetary values, to 2 decimal places. Okay, so the next part of this question, we're wanting to find out what is the total interest that Peyton has paid over the 3 years so far. And so what we need to know here is that our total interest that is charged on our loan is equal to the total that we've paid so far minus our balance reduction. So you may have done some work on this in relation to the amortization tables from the previous video, or you may not have. Here though, our total interest, so we can work out the total paid by taking our payment amount. So our total paid, we made 78 payments over that 3-year period. So remember that is 3 times 26 fortnights per year. And each payment was $1,704.14. So that will be the total that Peyton paid in that time period. And that comes out to $132,922.92. Our balance reduction will be the difference between the starting value, so the difference between our initial loan value of $350,000 and the balance at the end of the 3-year period. So that $262,323.33. And so the amount that's actually come off the loan, that balance reduction, is equal to $87,676.67. So now we can work out our total interest paid. That will be the difference between what we paid and how much came off our loan. Because remember that the payments are split between those two things, interest and balance reduction. And so that leaves us with $45,246.25 total paid off Peyton's loan. For another example here, we've got Alma who borrowed $12,000 to pay for a holiday. So that's our principal value or our starting point. She will be charged interest at 6.12% per annum compounding monthly. So we've got our interest rate and we know our compounding periods and our payment periods will be 12 times a year. This loan will be repaid with monthly repayments of $500. So our payment amount, $500. After 4 months, the total interest that Alma has paid is closest to. So just like the previous example, our total interest will be the total paid minus our balance reduction. And so thinking about what we have access to here, the total paid, Alma is making 4 months worth of $500 repayments. So she's making $2,000 worth of payments. So that's what she's paid in total. The balance reduction will be the difference between the starting point, the principal value, and the balance at 4 months. So what we need to do here in order to complete this question, we need to find what is the future value when n equals 4. So transferring that information into our calculator, we said after 4 repayments, so n is 4, we had an interest rate of 6.12% per annum. Alma's loan was for $12,000 and she was making repayments, so negative, of $500. Our payments and our compounding periods, there's 12 each year, they're happening monthly. So we'll go back round to future value and press enter to solve there. So at the end of after 4 repayments, at the end of 4 months, Alma still owes $10,231.33. Okay, so making note of that working that we've done. And note again, our future value is negative because Alma owes that money to the bank. So when we're now thinking about the balance reduction though, she started with $12,000. The current balance is $10,231. 231.33, and that gives us a balance reduction, that difference there, of $1,768.68, which means my total interest paid is $231.33. So our answer there is closest to A, $231 interest in the 4 months. So you can see that's an example of how we needed Finance Solver, or we could use Finance Solver to find one of the pieces of information that we needed to answer the question. And that's quite often the case. So now having a look at one special type of scenario to do with reducing balance loans. And this is often something you will only need to do if you've got Finance Solver. So here we're saying that at some point throughout our working, when we've calculated the payment that's required, there has to have been some rounding at some point. Either that, or as an individual, you've decided that, okay, the bank told me I needed to make payments of $1,704, but I've decided to round that up to $1,710 or something like that. So there will be a need to adjust the final payment. Either the payment will be slightly more than the normal or regular payment, or slightly less than. So in order to work out what is the final adjusted payment going to be, there's a couple of different methods. And the first example we're going to look at is using the method where we know the balance of the loan after all of the payments have been made. So what's left over at the end, and what we do is then add that on to the regular payment. And so we follow that process regardless of whether we owe a little bit or we've paid a little bit too much. The process of adding those values together will work regardless. Okay, so we're back with Alma, but some slightly different information here. So again, she's borrowed $12,000 and charged at the rate of 6.12% per annum compounding monthly. So making note of what those values mean, we have our principal value, or our starting point, we have our interest rate, and we know that our compounding periods are monthly, so 12 times per year. The loan is going to be repaid with monthly repayments of $850. So that's my PMT value, my regular payment. In order to fully repay the loan, she's going to make 14 monthly payments of $850 and then one final payment that will have a smaller value. The 15th and final repayment is closest to. So we want to find out what is the value of this final payment. So step 1, as we said, is to find the future value when we've reached our maximum number of repayments. So in this case, 15 payments in total. Then what we're going to do, step 2, will be to add that future value, so our final payment, will be our future value plus our regular normal payment that's being made. So we'll jump into our calculator and put that information in. Okay, so 15 payments in total, 6.12% was our interest rate, and now we borrowed $12,000. Our repayment, she's now making repayments of $850, and again, we're entering that as a negative value. Those payments are happening monthly, so you always want to just check that in case you've done a different question in between. Let's come back and find our future value. So after the 15 payments, we have a future value of $263.88. So notice that is a positive number. That means she slightly paid too much, $263.88 too much. So we're going to find that adjusted payment by doing this future value we've just found plus negative $850 and taking the sign with it. Okay, so our future value of 263.88 plus my PMT value, as we said, negative $850, will mean I'm getting a value there of negative $586.12. So the negative tells me that Alma has to give the bank that money. So I'm making a payment of $586.12. The closest amount to that here is option D. Now note in those options, as they often will do, the first step, obvious answer, is there as one of the options. So please make sure you're checking you've followed all of the working through and done all of the steps required, and not just stopped as soon as you've seen an answer that's appropriate. Another method for finding the final payment is when you may not have been given what is the regular payment amount. In this scenario, you should know what was the future value just before the final payment. So that means you've got one more payment to make. There are ways of doing that by calculating the interest as we would in an amortization table, but I'm showing you here how you can do this with your calculator. So in this scenario, we have Joseph who borrowed $50,000 to buy a new car. The interest on the loan charged at 7.5% per annum, compounding monthly. Joseph will fully repay in 60 monthly payments over the 5 years. So 12 months for 5 years gives you the 60 repayments. Immediately after the 59th repayment, Joseph still owes $995.49. What is the value of his final repayment? So we've got a few things here, and not all of the information is relevant. In this scenario, when we need to find the final repayment and we're told the balance just prior, we can use that balance just prior as our starting point, our principal value. We are going to make one payment, so N is going to equal 1, and we're going to find out what is the payment amount required so that my future value is 0, because I want the loan to be fully paid off and owe nothing. Okay, so if N is 1, we had our interest rate 7.5% per annum. We said we're going to use that $995.49 as our start point, and we'll come back and find the payment required so that my future value is 0. Checking that we've got our payments and our compounds set at 12 times a year for monthly. Then when we come back to our payment amount, this is telling us that I need to make a one-off payment of $1,001.71 in order to fully repay the loan, given the information that has been provided. And so we can see here, of the options provided, we have C as our best answer. Note here the obvious incorrect answer, A, $995.49. The reason why our final payment has to be a little bit more is between the 59th and 60th repayment, the bank has charged Joseph some interest. So it will always be more than what was owed just previous to that. So now we're going to look at a couple of examples which are the changing conditions scenario. So as said previously, sometimes in the middle of a loan or at some point throughout a loan, something might change. So the interest rate might change, the payment amount might change, the number of payments left to finalise the loan might change. Or it could be that we have a lump sum payment, so a change to the balance of the loan at some point. And so our key base approach is to firstly find out what is the future value of the loan or the balance at the point of change. So you're always wanting to first find what's the balance at the point where the condition changes. Then we apply the new conditions and we use this balance as our starting point, the principal value for the new conditions, and then play out the scenario depending on the question. So quite a typical example here, we have Xavier borrows $245,000 to pay for a house. For the first 10 years of the loan, the interest rate was 4.35% per annum and compounding monthly. Xavier made monthly repayments of $1,800. After 10 years, the interest rate changed And now Xavier makes monthly repayments of $2,000. And he could repay the loan in a further 5 years. So there's our change. The new annual interest rate for Xavier's loan is closest to. So the first thing we said we want to do is find what is the balance at the point of change. So from the information we have, the first scenario, we've got a principal value, we've got an N of 10 years times monthly repayments, so 120 payments altogether. We have an interest rate of 4.35. He's making payments, so a PMT value of 1,800. So we're going to firstly find the future value when N is 120, so at that 10-year mark. Okay, so transferring that information in, 120 payments, 4.35% per annum. A loan of $245,000, making payments of $1,800, and checking that our PPY, CPY are monthly. So the future value there is $108,219.16. So what we are going to do now is take that future value and it's going to become the new starting point for our loan. And so when we're noting down our process, we are taking that future value and it is going to become the new principal value or starting point. And this time we are then going to solve for our interest rate. So in the calculator, we go back to N. This time it was 5 more years making monthly payments, so 60 payments. We're going to come back and find the interest rate. My PV will now be the 108,219. A couple of things to note. Put in as many decimal places as you can read, or at least 4, so that you're not accidentally rounding too early and impacting your answer. And second thing, the principal value, remember, is always a positive value because Xavier now has that money again. And we're now making payments of $2,000, so negative 2,000. We want our loan to be paid out, so we want our future value to be 0, and we're going to solve for what interest rate would help us achieve that. And so there we get an interest rate of 4.14%. And so from the options there, we can see B is our best answer. So whilst it might look messy and complicated, I think using different colours to help you identify the different scenarios can be really useful. And knowing that your process is basically the same. Find the future value at the end of the initial conditions and then use that as your starting point for the next set of conditions. Okay, so this is what I would consider a challenge question in the changing conditions. So changing conditions is already a challenging application of reducing balance loans, and this one is a challenging version of that. So this is a real separated question, but with a good process, it is something that everyone can attempt to answer. So Ken has borrowed $70,000 to buy a caravan. He'll be charged an interest rate of 6.9% per annum, compounding monthly, and makes monthly repayments of $800. So this is our first scenario. After 3 years, so this is a point where something changes. After 3 years, Ken will make a lump sum payment of L dollars in order to reduce the balance of his loan. This lump sum will ensure that Ken's loan is fully repaid in a further 3 years. The repayment amount and the interest rate stays the same. What is the value of the lump sum payment? Okay, so first let's work out what was the balance at the time that Ken decided to make this lump sum payment. So firstly, what we want to find is what is the balance when the number of payments after 3 years, so 3 years of monthly repayments after 36 payments. The second thing we then want to find out, if he made a further 3 years of the same repayments with the same interest rate to finalise his loan, then what was his starting point to achieve that? So what is the present value for the final 3 years? So when the final 36 payments where the future value ended up at 0. So again, this is the challenging part, to think through how you can use Finance Solver to achieve this. And then finally, helping us put that together, the difference between the future value from step 1 and the starting point, or the principal value from step 2, the difference between those will be the amount of the lump sum. So 2 steps of calculations using Finance Solver to allow us to do a calculation to find that lump sum payment. Okay, so step 1, future value with initial conditions. So we're saying 3 years of 12 monthly repayments, so 36 payments in total. Our interest rate 6.9. Ken borrowed $70,000, so that's our principal, our starting point, and he's making payments of $800. So the future value after 3 years, he at that point owes $54,151.60. We would note this down. Now what we want to think about is what was our principal value. So what was the starting point in order to achieve a fully repaid loan, so a future value of 0, in a further 3 years of payments. So the only thing that has changed, we're now adjusting, we want our future value 0, and we're going to solve for the starting point of that scenario. And so we get there a principal value, or a start point, of $25,947.58. So we now know at the end of the first 3 years, he owed just over $54,000. But then in order to achieve that paying off of the loan, he needed to start at $29,947. So the difference there must be that lump sum value. Okay, so I've just transcribed all of those values into this space here. So we can see we're doing that subtraction to work out the lump sum. And when we do that, we end up with $28,204.02. Note here, I haven't rounded my values yet until the very final answer, because I do not want to round anything in part of my working. It's only the final answer that I will round off. So the lump sum for Ken, $28,204.02. As I said, that is a challenging version of a challenging application for reducing balance loans, but it's a nice way to show you how you can utilize your Finance Solver to find lots of different things for you. And I encourage you to seek out questions like this and practice a process that you can use so that if you do get one in your exam, you can be confident that you can have a go.